Hello friends, in this video we are going to learn about LCR series circuit. We have studied that what is the behavior of resistance, capacitance and inductance separately when AC voltage is applied to both of them or all of them. Here in this circuit we are going to combine all the three components which we have learned till now: inductor, capacitor and resistance. And what is applied? AC EMF is applied to this circuit. Now I will start this derivation by first drawing the phasors. Now because L, C and R, they are connected in series, what remains same through all of them? That is electric current. So for all these three components, first I will draw the current phasors. This is the current phasor along positive x-axis, here also along positive x-axis and here also in the resistance. क्योंकि तीनों सीरीज में हैं तो करंट की हर चीज तीनों के लिए एक जैसी होगी. Now in the resistance, what is the phase difference between current and voltage? It is zero. So the voltage across resistor is in phase with the electric current. In capacitance, what is ahead? In capacitance, current is ahead by 90 degrees. So I have to show that current is ahead of the voltage by a phase of 90 degrees. So voltage is behind, current is ahead. In case of inductor, what is ahead? The voltage is ahead of current. So I have to draw it in such a way that it looks like voltage is ahead of current by a phase of 90 degrees. Okay, all these three phasors have been drawn. And the equation, this time I will start with the equation of current, not with the equation of voltage. Why? Because I know definitely that current is going to remain same across any component in the circuit. So the equation of current is I equals to I0 sin omega t. And the phasor diagram, now these phasors are drawn differently. Now I will combine all these phasors in one diagram. See the diagram first. First the phasor of current. This is the phasor of current. Then drawing VR. This is the phasor of VR, voltage across resistance. Then the phasor of VL. VL का phasor कैसा होगा? This यहाँ से लेके यहाँ तक. This much is the phasor VL. And then drawing VC, the phasor VC. What is the direction of this phasor? Downwards. So VC यहाँ से लेके यहाँ तक. This phasor you see in downward direction. This is the phasor VC. Right? Now see, VR, VL and VC, they are otherwise vector quantities, but when I represent them by phasor, they all become scalars. तो टोटल वोल्टेज जो सर्किट का है वो तीन चीजों पे डिपेंड करता है: वोल्टेज अक्रॉस रेजिस्टेंस, वोल्टेज अक्रॉस कैपेसिटेंस एंड वोल्टेज अक्रॉस इंडक्टेंस. सो इफ आई ऐड ऑल ऑफ देम बाय वेक्टर एडिशन, I will get the resultant vector. The resultant vector will be of resulting EMF. So I am adding all these three vectors: VR, VL and VC. So first, how do we perform vector addition? First draw VR, then draw VL and then draw VC. Okay, what is the resulting vector? From here you started drawing. At here you finished the drawing. So this is the resultant vector. This resultant vector is the resultant EMF. Okay. Whenever you are confused in this diagram, just think of vector addition. Now see, in this triangle, see, this is the phasor of EMF, this is the phasor of current. I need to find the value of theta. Theta क्या है? Voltage और current के बीच का phase difference है. Alright, so first writing all the voltages. VR, voltage across resistance, I into R. Voltage across capacitance, I into XC, voltage across inductance, I into XL. These are all the voltages. And now using Pythagoras theorem, I can find the value of epsilon, resulting EMF. This side ka square and this side ka square. This one and this one. They have to be squared and then rooted. So VR square plus VL minus VC. This is VL minus VC. This square, this is what? This is the net EMF of the circuit. Alright, now because I have to tell you what this theta is, the phase difference between current and voltage. So in the same diagram, I will take 10 function, which is opposite side over adjacent side. For this theta, opposite side is VL minus VC and adjacent side is VR. So tan theta equals to VL minus VC upon VR. This is the expression of थीटा. यहां से थीटा का एक और एक्सप्रेशन आप ले सकते हो. पुट द वैल्यू ऑफ VL, VC एंड VR. द करंट्स विल कैंसल आउट एंड व्हाट रिमेन्स इज XL minus XC upon R. This is yet another equation from which you can calculate the value of theta. Okay, I have tell you what the magnitude of voltage is. I have told you what theta is. So I can now make the equation of EMF. EMF is equals to epsilon 0 sin omega t plus theta. कैसे हो गया? देखो, voltage is ahead of current by an angle theta, right? Just put that in your equation. Current, maximum current की जगह maximum EMF और sin omega t की जगह क्या आ जाएगा? Omega t plus theta, जो कि current और voltage का phase difference है. So this equation number 4 is of the resulting EMF. Okay, that finishes the derivation. Current and voltage का जो derivation था वो यहाँ पे खत्म हो गया है. But like in case of resistance, capacitance and inductance, ठीक है, ये current को रोकता है कैसे? resistance बना के. ये current को रोकता है कैसे? inductive कैपेसिटिव रिएक्टेंस से. ये कैसे रोकता है? इंडक्टिव रिएक्टेंस से. तो जब ये तीनों मिल जाएंगे तो ये करंट को अपोज करेंगे. ठीक है, वो जो तीनों का मिला के अपोजिशन होता है, दैट अपोजिशन वी कॉल इट बाय द नेम ऑफ इंपीडेंस. What do we call them? By the name of impedance. What is impedance? It is net opposition to current. Okay, whenever there is one component, we talk about resistance or reactance. But when two or more than two components get combined, we do not talk about resistance or reactance. The term used is impedance. All right. So how can you calculate the total impedance of the circuit? Very easy. See, from this phasor diagram, I have written this equation, tan theta equals to this, but I also know that tan theta equals to this also. पहले मैंने इस फेजर डायग्राम से ये वाला इक्वेशन लिखा था. अब मैं इस वाले इक्वेशन से एक और फेजर डायग्राम बनाऊंगा. XL minus XC becomes the opposite side, R becomes the adjacent side, and the hypotenuse will give you the resultant impedance. Very simple. थीटा यहां भी वही है, थीटा यहां भी वही है. So this is also theta. What is Z? By Pythagoras theorem, R square plus XL minus XC whole square. Or if you want to put the values of XL or XC, you can express it in this form of equation also. Right? So when the three components are combined in series like this, तो हमारा analysis पहले से easy हो जाता है. In capacitance, we did differentiation. In inductance, we did integration. But here, there is no need to do anything. Just draw phasor diagram and tell what is resulting EMF and what is resulting impedance. All right? ठीक है. अभी listen now. इसमें एक थोड़ा सा change आ सकता है. ठीक है. Suppose in this diagram, VL is upwards, VC is downwards. In this diagram, VL को मैंने बड़ा बनाया है, VC को छोटा बनाया है. So this angle is in the first quadrant. What will happen if VC is longer and VL is smaller? ठीक है, VC बड़ा हो और VL छोटा हो तो ये वाला डायग्राम कैसे बनेगा? Let me show you how that diagram will look like. See, first I will draw the phasor of current. This is the phasor of current I, and then the phasor of VR. This is the phasor of VR. Then the phasor VC. VC बड़ा है ना? Suppose करते हैं this is VC, and then I will draw VL. तो VL ऊपर की तरफ होगा. This will be VL, and this magnitude will be VC minus VL, and the angle will go in fourth quadrant instead of first. तो यहाँ क्या होगा? Here, what you will write, the equation of voltage will also change. Instead of plus theta, it will become minus theta. ठीक है, तो ये थोड़ा सा इक्वेशन में चेंज आएगा, राइट. सो द डिफरेंस, if VL is greater, the graph, the phasor diagram will be like this. If L is smaller, then the graph will be like this in the fourth quadrant. I hope you understand all this. This lecture can be used in form of notes as well as for the purpose of understanding. Thank you.